sort of protect yourself. Today we're seeing attackers who are sending out multi-vector, multi-layer attacks, and we really need to think about what our strategies are going to be for each of these layers. So we're going to be going into each one of them and talking about what are we doing in each layer to sort of protect against attacks. What are sort of the strategies that you can sort of use as you're building these layers, proactively to either block attacks, be monitoring them, or give yourself breathing room to sort of consume the attacks. So applications, stuff like web apps, the actual servers. What are we doing in the Linux kernel, and in IP tables? How can load balancers help? What's the role of firewalls today? What about the physical networks? There's a lot of interesting things that we're doing at the physical layer today to help with these. And then third-party scrubbing services, talking about like BGP swings, and how they can do layer 7 mitigations today. And then third-party CDN services, stuff like Cloudflare, and how does that fit into an overall strategy? So just as an example, some of the applications and tools we'll be talking about are up here. And as you can see, there's a healthy amount of open source technology that's being used. And these are just obviously examples of some of the things you can use. But we'll talk about what we've used and how they've been effective for us. So, okay, so big scary slide here. Why do we need to worry about this? So we're noticing now with the proliferation of bitcoins that the attackers have this sort of brazenness about them, because they understand that if they're asking for ransom, essentially the money can't be traced back to them. And before, maybe they were using PayPal, and it might have been a little bit easier to track them. But with bitcoins, they can really be confident that they're fully protected in that sense. And it's gotten to the point now where attackers are just sending out a small layer 7 attack to get someone's attention, and then followed by an email. We don't get 25 BTC or 100 BTC, we're taking you down. And it's gotten to the point that actually, governments are now sending out like warnings to their enterprises that this is on the rise and this is happening. Part of the reason that it's on the rise is because it's so simple to do. You can go onto some of these public sites, these boosters or stress testers, and you can buy a pretty healthy DDoS for about $5 and take down one of your competitors. So now this is referred to as DDoS as a service, which is kind of cool. The Lizard Squad attack of PSN and Xbox, from their perspective, they were just stress testing their networks, but they did a great job of taking them down. And a lot of these are sort of promoting themselves as legitimate legal sites where you can go and stress test your own network and put in your own URL and see how good your security is. The difference between legitimate stress testing sites and ones that are really just masking as such, but are really services where you can buy attacks, is that there's no sort of verification of ownership on the ones where you can attack other people. If you're using sort of like a service like Google, they'll make you go through a verification process to ensure you own the site. With these sites like this, Rage Booter, there is none of that. So IoT is also going to become relevant with this as well. So over the last 5 or 10 years, desktops became sort of like the method of choice for botnets and to distribute attacks. So IoT, or we like to say IOCT, Internet of Compromise things, we're going to see that all move to sort of like these like a mobile type platform. If you look at Android, there's about a billion or so Android devices out there, and we know that they're susceptible to attacks. So you take these devices. You put them on an LTE network, and you hack them, and now you have this great platform for mobile attacks. So it's essentially everything that happened with desktops being moved there. And if we're generous and say there's only like 0.1% of these devices that are hacked, that's still a 100 gigabit attack, and that's being really, really generous. So there's a huge potential there for these devices to participate in these botnet attacks. And we've already seen these funny stories about professors or people who have set up these smart homes and had like the light bulb, DDoS the controller, and the whole house, is locked down and has to get rebooted. So that's definitely not going to be helping us, as sort of time goes on. The attacks are also becoming more sophisticated too. We see a lower number of total attacks, and the reason there's less attacks is because they're able to do what they're looking to do with less attacks. So if they're using a more sophisticated layer 7 attacks that require very little bandwidth to kill applications or sites, they don't have to use these sort of larger, multiple, dirtier, volumetric type attacks. And you can see that the layer 7 attacks are on the rise. And they're certainly going to be getting more sophisticated. We're also noticing that the botnets are getting smarter. The botnets, whereas before they were crude and they could like pull up a URL, they can now they can ingest and follow cookies. And we're starting to see botnets that can also actually parse and follow JavaScript as well. So there's a lot more that can be done with these botnet networks. So a quick note about us and sort of why we're talking about this. So we're a managed service company, a cloud service provider. We own and operate a few data centers around the world, New York, Montreal, Los Angeles, and Amsterdam. And what we do for our customers is we provide them with full stack management. So we take ownership and responsibility of our customers' entire stacks. So it's full infrastructure outsourcing, full outsourced DevOps. So we're owning the CDN layer, security for every layer, how the load balancing is being done, how it gets scaled. We own the application servers, LAMP, Nginx, the caching layers, everything that you see up here. And there's certainly a lot that we have to do as a company to ensure that our customers and their infrastructures are secure and that there's sort of no holes in each of these layers. And that's essentially what our value proposition is to our customers. So there's a lot of larger customized clustered setups that we're managing. So the first layer is the application layer. So here we're talking about maybe open source software like WordPress or stuff built on Cake PHP or Drupal, or even enterprise applications or sort of Java-based apps as well. So what we've seen is it's just so simple to take these sites down with very specially crafted URLs. If there's like a search, if it's a search engine, all you got to do is construct some sort of search query, which is making a nice call to the backend, a database, and hit the site with about 50 of those a second, get the database to lock up on the backend, and you've taken them down. Really simple to do. It stays under the radar for these. They're like sort of like the firewalls or maybe network-wide sort of DDoS detection. It doesn't raise any alarms, and it's easy to take these guys down. A lot of it comes down to poorly written SQL queries. There's a lot of custom applications out there which might function. Maybe you have a coder who wrote an app that works, it technically works, but was it written to scale and to be secure? There's a huge difference between that. And a lot of our customers, they'll just hire a freelancer and it works. And then 6 months later, the guy's gone. You don't realize that it's susceptible to all of these different things. We also see people just exploiting, like where can I post to? Comment pages, stuff without catchpas, and stuff like that, or even just simple, state exhaustion on like Apache and Nginx servers. Again, you don't need a lot of requests per second to make a lot of these servers fall over. And here you can see what I was talking about before with the increased capabilities of the botnets. So the way that we like to protect the application layer is first, what can the application do itself to protect itself? We don't want to muck with it. A lot of these applications and frameworks have modules that you can add on for firewalling. So WordPress is we talk about that a lot because it's pretty popular and it's notorious to take it down easily, and it's got all these security vulnerabilities. But there's tons of third-party sort of firewall modules and plugins for it that you can add that do a pretty good job of protecting it on a layer 7 type layer. There's also like Apache modules, mod evasive and mod security, which give you pretty good WAF functionality on the server. They might not, generally you'll tie those into sort of a signature rule set that's up there on the internet that you might download every night. They're really not as going to be as updated as much as maybe sort of like a firewall's built-in rule set, but they give you pretty good capabilities. If you have those running, you're not going to see hits in your application server log about with like insert. You're not going to see query strings with like insert or selects or silly things like that you should never be seeing to your application. Next thing is caching. So everyone always associates caching with speed. It's all about increasing the speed of the site, but caching is an extremely important security layer as well. To the extent that you cache the application as far away from the application as you can, you're going to shield the backend from these sort of dynamic requests that easily take down sites. So again, if you're not making SQL calls or rendering PHP on the fly, you're giving your sort of infrastructure all that much capacity to consume to consume these attacks. So maybe maybe the application falls over at 10,000 requests a second instead of 50 requests a second. And caching has been talked a lot about forever. There's really straightforward ways to add caching to applications. memcache, doing it with opcode caching, and we've even done this. As an MSP, we don't have access to change our customers' applications. We can make recommendations, but that's up to them. We've even done stuff like create a simple 5-line script to pull our customers' index.php, do some checks, and output it to an index.html, and cron that to run every minute. And that's greatly increased the amount of load and the tolerance for these attacks that our customer sites can handle. And the other point is to just follow best practices for scale, because if you're increasing the infrastructure's ability to perform, again, you're giving it all that much more capacity to consume these smaller level attacks.
So the next thing is really getting into the server layer. We identify a lot of issues with applications, and there's a lot of things that you could do with applications to kind of thwart attacks, but there's only so far you can really go with applications. So the next thing up is really modifying how the server reacts to basic things. Simple things like per IP rate limiting, flood rate limits, and even send cookies should be enabled without a question. First up, we have sysctl stuff. There's a lot of different ideas and terminologies and stuff on the internet. Even fights break out over some of these parameters. But for all intents and purposes, these are kind of like the more top five or six sysctl parameters that we see and we use on a regular basis. So enabling send cookies often will prevent and sometimes block send flood attacks. The other thing is enabling or increasing the number of outstanding send requests that are allowed to the server. The send backlog on a lot of Linux distros is fairly small. So raising that, even here we have 4,096. I've seen 100,000 to 300,000 on some of these for high impact, high traffic servers, because they need the standard TCP/IP, SYNAC, and ACK, the three-way handshake, to handle some of these high traffic requests. So raising it even higher will give it more capacity for some of this backlog. And then also, as a side to that, you reduce the number of potential ACK replies. On a lot of distros, the default is 5. We recommend reducing it down to 2 or 3. Of course, your mileage may vary on a lot of these sysctl variables, so take it with a grain of salt and test it. Don't just throw stuff in there and reboot. It could cause a lot of problems. And then the next thing is a fairly obvious one in a lot of states, is reducing the number of connections in time wait state. If you run a netstat, you'll see a ton of connections in time wait state. The default on a lot of distros is 60 seconds. A lot of times this could be reduced down to even as low as 15 seconds. But this is one of those things where you want to do it in increment states. So drop in on the 45, make sure that your application and everything is operating to your spec. Drop it down to 30, do the same thing. Drop it down to 15, do the same thing. I've even seen one of our servers, a self-managed server, had a 5-second timeout, which is impressive. But their application was made for that kind of thing. And then we move on to IP tables. A lot of things that I've seen in the past is you get a send flood. You see in varlog messages or varlog syslog, NF contract table full dropping packets. That's IP tables connection tracking that's just filling up. It's not able to handle it. So in IP tables, you could just drop those. Or if you want to, you could rate limit it and drop it at the same time. So here we see that it's dropping any send flood that's after a 100 per second limit, with a burst of up to 150 before it'll drop it. Next thing is dropping excessive RST packets to avoid Smurf attacks. We don't really see a whole lot of Smurf attacks anymore these days, but they're still out there, and it doesn't hurt to really block them. The next thing is very clear, dropping invalid packets. Why do you need them? You most likely don't. So get rid of them. And then blocking bogon networks, blocking RFC 1918 IPs. A lot of people will say, well, I use these on my internal networks. Well, great. You often have a secondary interface, an intranet interface for those IPs. So you could allow those IPs only what you need. Some people use Keep Alive D, multicasting. Allow that network on your internal interface, but block it on the external interface. Anywhere you don't need it, don't allow it. Reject ports, protocols, and IPs that aren't in use. Are you really using UDP to port 80? Most likely not. Fail to ban is a very popular application. There's an alternative to that, SSH guard, but fail to ban kind of really encompasses all that stuff. And then being mindful of NFS overhead. One thing we say with that is stop logging to NFS. There's no reason to do that. We see it quite often, and it's really, really bad. Another thing with NFS overhead is oftentimes people will run their applications on NFS. With large server clusters, you want a nice, single point of content where you upload once and it's shared across everything. So a lot of people will have these solid-state NFS content servers that they run pretty quick, but NFS still has an overhead. So just keep that in mind whenever you're doing that stuff. The next up is load balancers. Believe it or not, load balancers can shield application servers from standard attacks. Most of them are already operating on layer 7. So you have the ability to perform custom layer 7 rules and regex and even do HTTPS matching via SSL offloading, which is big. They also, we found in our research and practice that traditional appliances don't really do too well. They're too rigid. They're not as flexible as what we need nowadays. So like the next gen ADC stuff is starting to provide load balancing, WAF, and cache all combined into one package, which is really cool. Our DIY kind of stuff is we use Ansible to deploy HAProxy servers on Debian or Rail, CentOS sometimes. Use csync to keep configurations in sync between them, keep it all local. Very simple stuff like that. A lot of load balancers also have the ability to integrate with third-party software pretty easily. So you could tie into MaxMind's GeoIP database, block high-risk countries, Ukraine, Russia, stuff like that at the load balancer level before it even gets to the server. That way you don't have to worry about HT access stuff and file system traversing and all that, which is also more overhead. Automated blacklists are also a big thing as well. A lot of load balancers will also tie into other caching applications. So Varnish, Nginx, and stuff like that have a lot of tie-ins to load balancers and even do their own load balancing in some cases. We prefer to use HAProxy. It's open source, it's very fast, it's very lightweight, and it works really well. We often do connections, rate limiting by IP. We can also do bandwidth usage. We can monitor bandwidth usage on a per IP basis. So if we find an IP that's doing an inexorbitant amount of bandwidth, it's probably not good. We could also block clients that aren't respecting RFCs, like SMTP and stuff like that. Since the load balancers are operating on layer 7, we could do regex and string requests. We could also block user agents. Google bots, Baidu is a big one. Yandex, all these other things you most likely don't want in certain aspects that don't respect the robots.txt protocol. And any layer 7 header you could block against or match against and do certain things with. You can rate limit, do whatever you want with them, which is really good. They also often provide vulnerability scanning in a sense, where you could drop invalid or truncated requests. You could deny or tar pit requests. If you see IPs that are getting too many failed authentications, it's probably hacked. Block it. If you see an inexorbitant amount of 404 requests from certain IPs, it's probably malicious. Block it. And this is kind of like our baseline HAProxy ACL list that we use. There's a whole bunch more options out there. Check out the HAProxy config documentation. It's very well done. There's a lot out there. So here, we're setting the stick table to 250,000 entries, and each entry will expire after 5 minutes. So we're blocking with rate limiting. We have the ability to whitelist IPs from a text file that'll also do CIDRs. So if you have an entire /19 to your enterprise, your office has a /24, you could whitelist your office. That way your monitoring and everything won't get caught in the blacklists. You could also put IPs in a blacklist text file and block on that or rate limit on that. There's a lot of things you could do. It's really cool stuff. And this here, you see that we're blocking at layer 4 and layer 7, TCP request and HTTP request.
So next up is firewalls. There's a lot of capabilities with the application itself and the load balancing. Firewalls are still an integral part of the overall solution. Certainly when we talk to enterprise customers, everybody wants to see the firewalls and the network diagrams. They're required for compliance, PCI and HIPAA compliance between the layers. So all the firewall vendors now are really focused on adding the WAF capability to the firewalls themselves. It's been pretty common. Some vendors, say WAF is not enough. So Palo Alto has sort of gained tremendous growth by having this sort of next generation sort of WAF capability that spans across all their applications and all the different sort of segments of the network. But there's still a place for open source in all this. So we do deploy physical firewalls for our customers or virtual firewalls. We're using Cisco's and Juniper. But again, like Logan said, sometimes those platforms are just too rigid and they don't give you the ability to just SSH in, modify a configuration file, reload a service, based on different things that you're seeing at that moment. So MikroTik is an open source Linux-based firewall that we use, and in the same sense, all the flexibility that HAProxy gives us for load balancing, MikroTik gives us on the firewall level.
One of the really cool things we see with MikroTik and that we use in practice as a hardware appliance, you could deploy MikroTik router OS to VMs. You could deploy it to bare metal, and you could even buy the router boards yourself for smaller stuff like I have in my house. But with the bare metal deployments, they do support built-in virtualization. So if you have a Linux router that you want to handle, if you like pfSense or something like that on BSD, sorry, or you have your own favorite WAF application that runs on Linux OS, you could spin up a VM, a Linux VM, inside of MikroTik as a hardware appliance and route all your traffic to the WAF or to whatever you want inside that Linux VM. It goes with whatever hardware you're doing. If you have 16 gigs of RAM on this MikroTik, you could put as many Linux VMs that you want in there. It's really cool stuff. Another really cool thing is dynamic address lists, which a lot of firewalls don't have. So you can set policies. SYN flooding, for example. You can set a policy for if it detects that there's a SYN flood, you could add those IPs that are participating in that SYN flood to a dynamic address list and add another policy on the very top of the list that will drop all of those packets right up front without even worrying about it. You could set the address list to expire after a certain amount of time per IP, or you could leave them persistent. It's really cool stuff.
Block SSH hooks.
Yes, you could do a whole bunch of stuff. It's virtually endless. It's really cool stuff. Another really cool thing is, it's got a GUI, Winbox, or as a desktop application, or WebFig via the web interface. You could also SSH into it and do all this stuff. It has built-in packet sniffing via an application called Torch. So you could do your packet sniffing on the firewall really simply, really easily. It's very configurable. And it has great IPv6 support. But one thing we see a lot with IPv6 is these people will put, clients will put IPv6 on their firewalls. And they'll say, oh, cool, I'm IPv6 capable now. I have quad A records. But they forget to put the policies into the IPv6. So now their IPv6 is wide open. Their IPv4 is nice and secure. But, all it takes is a really good person to say, oh, look, there's an IPv6, there's a quad A record. There's no firewall rules. It's wide open. So keep in mind with all that stuff.
One other note on Micro. So MikroTik was brought to our organization by one of our network admins who actually immigrated here from Iran, and he was running like the second largest ISP over there, all on MikroTik. So he was taking in full BGP routes from his transit providers, running it in core and distribution. And, it does support all those routing protocols, and it works pretty well. So it's very capable. We talk about like, well, how many sessions and what's the bandwidth. It's just a matter of throwing more hardware at it. But from a software perspective, it's pretty lean and it really works great. We also like it for just like site-to-site VPNs and VPN capability. A lot of times that we have to interconnect on our firewalls to our customers' on-prem devices, we notice a lot of incompatibilities when we try to interconnect like Juniper and Cisco and stuff like that via site-to-site. We found that MikroTik just plays nice with all of them really well, and we were pulling our hair out before and having to support everything out there, but now it's so like our de facto VPN concentrator is MikroTik.
You find on Cisco's that you have to cycle the JNFD between MikroTik and Cisco, so I get like tunnel drops, and if I schedule like once an hour just to.
We've been able to tweak it to just work consistently well.
Yeah. Another thing is, it's got cool graphs, so you could appease your managers very easily. But I mean, the GUIs and everything have really, really in-depth functionality. You can drill down very tight. And this is just an example of one of the, I believe it's just an interface. Shows you what's going on, how many packets per second. It has a little graphs for it. It's just really cool stuff.
It is. It's tough to find open source software with graphing capabilities that actually works consistently over time and works well. So yeah, this is very helpful. In fact, we've had customers who come from sort of enterprise type of firewall devices come to this and be super happy with it, and it'll work for those type of customers. And MikroTik itself does offer commercial support. So for those enterprise customers, they'll accept it because it comes with that, and you can get the license like $45 or something. It's ridiculous.
You can get affordable 10 gig port.
Yeah,
it does support 10 gig.
Yeah, you can actually buy it as a physical appliance, all in the box.
Yeah.
So the next layer is the network layer, the physical network layer. So this is a network diagram from one of our locations, one of our pods, and this is a pretty straightforward sort of top-down topology. Now in some of our newer locations, you might see like sort of more like a spine leaf. So here we have edge routers up at the top that connect to multiple transit providers, multiple peering exchanges, and this is sort of oversimplified. Then we go down to our core, and then we have layer 3 distribution islands where all of our customers live on. So there's a lot that has to be done here to sort of not allow attacks to sort of proliferate down the network from the edge and make its way into our lower layers and sort of access switches and all that. So some of the things we do for the network layer, and a lot of this is stuff that's been around probably since the mid-90s. It might not be too interesting, but it's worth noting is blocking the Martians at the edge, blocking bogans, which bogans are essentially public IP ranges that have not been allocated to anybody yet from ARIN or RIPE. So because they haven't been allocated, you shouldn't be seeing any traffic from them. But what you do need to do is if you're going to block them, you need to automate it. So there are these publicly available lists because those blocks do get allocated, and if you block them and then tomorrow it gets allocated and it becomes legitimate, you're now blocking legitimate traffic. So that's been around for a long time. Unicast reverse path forwarding basically means that if you're accepting a packet from the internet, you want to be sure that your routing table is telling you that it's actually a source IP that you can route back to. Because if it's not, if it's a spoof packet and you can't route back to it, you don't want to accept that. Same thing for outbound. We don't let traffic leave our network that is not coming from a destination that we've identified as being part of our network or part of our IP range. And that's going to prevent spoof packets from leaving our network, and it might prevent retaliation attacks for outbound DDoS as well. Next thing is you want to monitor the actual physical network and see what's going on. This is again pretty standard stuff using NetFlow or SFlow collectors. There's plenty of open source collectors out there, or the Arbor stuff is pretty popular in the enterprise. And then the last thing is reflection attacks are real popular now. So NTP and DNS reflection, and those can be tough to deal with. What we've done on our network is we actually block all inbound NTP traffic, and we block all outbound NTP traffic. So this is really good for our network. The problem is our servers can't actually sync up to time servers, and that's not so good. So what we do is we reroute outbound NTP requests to our own NTP servers, and those are allowed to poke through the firewall, and we provide that as a service to our customers. There are certain customers that don't like that, so we'll let them poke through as well. But once we did this, the amount of NTP reflection attacks decreased tremendously. And the other thing is we don't manage all of our customer servers, so we can't force them to sort of fix their vulnerabilities. So this certainly helped. DNS, we couldn't do the same thing with that, so we just have really granular reporting on when and if we see a server on our network that is participating in a DNS reflection attack. Last point to note is, like Logan mentioned before, IPv6, it's kind of like the Wild West. Just on an allocation perspective, /64 has become sort of the de facto smallest common denominator for IPv6, which is kind of silly in a way. Now you see providers, if they're trying to block spam from sources, they're not looking for single IPv6 addresses. They're looking for /64s. So in essence, a /64 is equivalent now to like a single IPv4 address. And if you are allocating /64s on your network, you got to be careful because people who have those can easily fill up your NDP tables or like your ARP tables and exhaust those on your routers. Next that we're doing on the network is, again, pretty standardized stuff, but being able to remotely black hole an IP address on your network quickly and automatically, being able to tell your transit providers that you don't want traffic destined to a specific IP to come into your network. So that's like a quick and easy way to, if you see an attack, to basically not let it come into your network. The problem is that website, let's say, or that IP is black hole. It's no longer functioning. So what you're doing, if you're black holing, is you're doing the attacker's dirty work for them, or you're essentially letting them win. So there's other things that can be done that we'll talk about instead of black holing. One of them is BGP FlowSpec, which is sort of this new protocol that's being adopted now, which provides you with a lot more capabilities at the physical layer. Instead of just black holing, you can build policy rules based on particular attributes of the attack. Maybe there's a certain packet size or certain source and destination IP characteristics. Instead of just blocking the traffic, you can rate limit it, you can police it, you can reroute it to internal scrubbing farms. So that's sort of like the next step up from simple black holing. And a lot of the flow spec stuff is now being done in the ASICs with the hardware providers as well. So here's just a screenshot from one of our NetFlow collectors. This happens to be Manage Engine. There's a lot of really great open source ones out there. So that's like the pretty. And on the bottom is the quick and dirty. That's us SSHing into a box and just saying which IPs on our network are receiving the most traffic at this moment in time, or what's the largest conversation. And that's being done via like an open source NetFlow collector. Which one was that?
NFSyn.
Yeah, which is pretty popular. So the pretty graphs and all that are great, but sometimes you just want to log in and see what's going on. Especially if there's a large enough attack where you can't reach your network, having a box on an out-of-band access, so where you can just even just SSH to your phone and run this is pretty straightforward. But again, the point is not to have your network become unreachable to begin with. So that's when third-party mitigation comes in. Has anybody heard of third-party scrubbing farms or providers like Prolexic or Black Lotus? So the way this works is, on a network where you're speaking BGP to your providers, you're announcing your IP space out to your providers, who are then propagating it to the rest of the internet. So when an attack comes in, it's coming in through your pipes. So the way the third-party scrubbing works is, when you see an attack coming in, you tell your third-party scrubbing provider, you tell them, hey, this /24, this C class is getting attacked. I no longer want the attack coming to my network. They announce that C class from their network. And then, so they're announcing it via BGP. The internet routing table updates in about 30 seconds. The whole world now is sending all that traffic to them instead of you. They clean the traffic, they remove the attack, and they send you only the clean traffic back through like a GRE tunnel or some sort of private line. And again, this has been around for a while. Prolexic started this, probably around 2002 or so. And there's other companies. We happen to partner with Staminus for this, but it's pretty straightforward. Armor Networks has made a whole business of selling these very expensive scrubbing boxes, and today there's a lot of other options. So what you get by using a service like this is you get on-demand scrubbing capability. You only turn them on when you need to, and it is one of those options of last resort that you're using only for those large volumetric attacks when there's so much bandwidth or packets coming in that your equipment can't handle. The other thing is, if you have a scrubbing farm interconnected to your network, especially automatically, you never have to worry about being in the business of ensuring that you have enough capacity to consume attacks. So if you have 200 gigabits of capacity to the internet, an attacker can have 300 gigabits. So now it's no longer your problem. You're paying for that with the scrubbing provider. They're giving you an SLA around how much bandwidth, how much attack bandwidth they can consume on your behalf. They've also started doing layer 7 mitigation via BGP swings too, where they're taking the packets internally, they're rerouting them to their own, Squid or HAProxy farms, and sending it back to you. Traditionally, they were only able to do layer 4, and they would want to do a DNS swing for layer 7 capabilities, but a lot of them have figured out those issues as well. So if you can combine this mitigation capability with the automation of that event of swinging over, you can have sort of automated DDoS mitigation for any size attack. So to do that, they typically deploy an on-prem device to sniff your network or take in NetFlow. They start to understand what normal traffic patterns look like on your network for IPs. They understand standard deviation, and based on thresholds that you set, when they see an attack, they'll automatically swing over to the mitigation.
Oftentimes, this is also like a span port or a network tap. That way, they're getting your full traffic as a mirror.
Now, be mindful that they might be using that data to build some sort of back-end, big data analytical, analysis play too. So, look at the contracts because they'll carve it out if you don't want it. The other thing too is oftentimes you're telling your scrubbing partner what you want mitigated by communicating with them over the internet. So if an attack is so big where it actually takes down your internet connection, you can't tell them what you want them to announce. So there's sort of like fail-safe methods that you want to have in place where maybe there's an API call or there's an interface, or you can call them and say, hey, please announce this route on my behalf. Because or even if something goes wrong, if your BGP session drops with them, the attack is going to come back to you because they're withdrawing their announcement.
And the last layer of the whole thing is third-party CDN proxies. Now, for better or for worse, these are an always-on kind of thing, where you often change your DNS to point to them. Big examples of this are something like Cloudflare, where you'll change your DNS to their name servers or to their IPs, and all of your traffic will always go through them, and they'll handle DDoSes and mitigation and stuff like that. These types of third-party services usually work pretty well out of the box with popular applications, only because they've seen just about everything out there. They know what the signatures look like. They know, what to look for and how to behave. These are normally pretty simple ways to handle many security touchpoints, caching as a security option, and CDN, reducing load on the servers. WAF capabilities are often a big feature of these kind of services. SSL offloading, you could also, a lot of them come with SSL offloading where you could upload the certs to them. That way they could, protect your SSL traffic as well as your non-SSL traffic. And most of them will also do custom rules. Sometimes it's kind of like a pay-to-play kind of thing where you have to upgrade to a bigger package in order to do custom rules, but they often have it. Most of these are really easy to use for beginners. It's just changing your DNS and letting it do its work. They also often have more enterprisey kind of things. If you are a bigger company, you need more SLAs. Edgecast and Fastly will do dynamic application caching. A lot of times, your sysadmins will spend hours, days, weeks, months writing VCLs for Varnish, and they get it perfect, but you can't handle everything yourselves. So instead of ditching all of that stuff, you could upload your VCLs to something like Fastly, and they could use your VCLs that you spent all your time on and not waste your money. And they could cache all that stuff at a higher layer across the world. A lot of these also have mid-tier origin caching as well, which is very important at scale, especially with CDNs and stuff like that, where you can select, say, our data centers in New York. We only want the POP that's in New York to access the origin servers, rather than 200 nodes from all over the world hitting my stuff all at the same time. I want to reduce that. So the New York POP will cache everything, and everybody else in the world will hit those higher capacity POPs. An option of last resort is they often will allow you to just set up a CAPTCHA. It's kind of gross, but you can set up a CAPTCHA for user verification, where if they detect that there's possibly a source IP causing issues, in order to access the entire site, it'll just ask for a CAPTCHA verification before you can go further. It's not really a complete solution for these kinds of things.
It's great when you see that, because
Yeah.
if a security company is employing a CAPTCHA to do user verification, it's basically letting you know that they had no way to defeat the attack and they sort of give up. So like Logan said, it's pretty gross. And keep in mind these are not complete solutions. Oftentimes attackers start looking at infrastructure before the attack happens, and it's pretty straightforward to sort of guess an origin address or look at source code and sort of see other assets that are important to the rendering of a site that might not be protected by these third-party proxy services. So they're definitely good to start with, especially if you're like a startup and you just want to get up and running. But they're certainly not a complete solution. These are some of the companies that are doing that right now. And the last note is that I think one of the things that we're going to start seeing in the future is sort of more proactive defense on our networks, where companies like ours are employing sort of honeypot type strategies, where maybe if a customer is not running WordPress, we'll add an overlay with all these other URLs that are accessible to make attackers think that maybe there is WordPress, or maybe there's these vulnerabilities that really don't exist, and we'll honeypot all that in. So as an attacker tries to investigate how they can take somebody down, we'll start gaining data on who's looking at them, who's trying to attack them, and we'll know that an attack is coming before the attack actually starts, and we'll be prepared for it. So we're going to start to see third-party providers who are willing to have these sort of overlay honeypot type services on top of traditional infrastructure, where you don't have to change anything to get those. And I'm sure the third-party proxies will start doing that, because they already sit between the application and the customer, so they're in a really good position to do that. But thank you guys for coming. Any questions?
Cool.
So,
Oh.
one question. With GeoIP, do you have better success with blocking the list of outside countries or including only what you want? So, because the inclusion list would be smaller, right?
If our clients know their customer base, sure, we could block everything else and use inclusion lists, and we have seen that happen where clients know their traffic is only going to come from the U.S., or they only want U.S.-based traffic or European-based traffic, or specific countries in the U.S. We have seen that, and it works very well. For those that have stuff very globally, they're not really sure. They can't really gauge that well, and neither can we, because we don't know what their business model is.
And the block lists are more effective in that case.
Right, blocking the bigger high-risk countries. You could also do rate limiting on GeoIP. So if you know that there's possibly other countries out there that could be high risk, but they have known traffic and known business in those countries, you could rate limit those based on the countries as well. So it's very, very useful, very easy to do in some cases.
Thanks a lot. We'll have the slides up. If you guys wanted to download the slides, they'll be on my Twitter later today. Thanks a lot, guys.
Thank you.